then I can send you the recording later so you
Yeah,
can
that's
watch
fine.
it. Okay, perfect. All right, so can you see my screen?
Yes.
All right, so this is the first problem that you had, and this first problem here was asking for the area of the area of the sector, so just of this region here, correct?
Mm-hmm.
All right, and they're telling us that the angle is 3 pi over 4. So what is the formula that you've been using for this?
I've been finding the circumference of the circle first.
Okay, for this one it's area.
Okay.
So we want to take actually the area of the circle, pi r squared. Does that make sense?
Yes.
Okay, so pi r squared, our radius here is 16. So I believe 16 squared is 256. That's where that 256 possibility came from. All right, so then once you had that, what did you do?
Um, do you divide it by pi?
What you do is the formula, and I'm going to write it up here, is the measure of the angle divided by 2 pi times pi r squared. Or sometimes we do by 360. No, that's it. All right, so the m represents the measure of the angle and or the arc that we're talking about. So this is 3 pi over 4. And the reason we put it over 2 pi is because 2 pi is the whole circle, all the way around. Does that make sense?
Yes.
Okay. So to take 3 pi over 4 and divide it by 2 pi, so that's really over 1. So when you divide a fraction by a fraction, you multiply by the reciprocal. So that'll give me 3 pi over 8 pi, and so the pi's are just going to cancel out. Does that make sense? So I got this is the measure of this angle, which is right here,
Okay.
divided by 2 pi, which means the whole circle.
Mm-hmm.
Okay, so that's going to, when I do that division, I get 3/8. So this is 3/8 times that area of the circle, which was 256 pi. I don't have a calculator in front of me right now. Hang on one more second. I'm at my daughter's house for dinner, so I brought everything in my bag. So I don't have it all handy dandy. Let me see here. I'm hoping I brought a calculator with me, but of course I did not. Okay. So let's see if I can do, I'll just have to do it the longhand way. Do you have a calculator with you right there? How many times does 8 go into? So it's going to go in 32 times. So 3 times 32 pi is equal to 96 pi. So that's where that answer comes from. So the key here is the area of a sector. The formula is the measure of the angle divided by 2 pi, because that's a whole circle, times pi r squared, because that's the area of the circle.
Okay.
Does that make sense?
Yeah.
All right, so let's look at our next question here. All right, the next question has to do with finding the measurement of the arc E. I don't think I grabbed my pen. Okay, there we go. E or FEH. They want to know what is the measurement of that arc. They are telling you that the measurement of this angle is 50 degrees. So does that part of it make sense to you?
Yeah, and then isn't arc FH 100?
No.
Oh.
But what we do know is that this, if you look at just FH, which is this part here, plus this whole part here, all together that's 360 degrees. Would you agree?
Yes.
So this part here is 360 minus x. What that basically means is that if x were 100, it'd be 260. If x was 90, it would be 270, etc. Correct?
Yes.
All right. This is what we refer to as an exterior angle. It's an exterior angle because the vertex is on the outside of the circle. So the measure of an exterior angle is equal to half the difference of the two arcs. So in this case, we know that this exterior angle is 50 degrees. They're telling us that. So we want to take half of the difference between these two arcs. So that's 360 minus x, which is the first arc, minus x again, which is the second arc. Does that make sense? Does that make sense? Okay, so to get rid of the 1/2, we just multiply both sides by 2, and we get 100 is equal to 360 minus 2x. And I got that 2x by negative x minus x is minus 2x.
Okay.
And so then what would I do to solve from here?
Well, can I ask where
Sure.
the second x came from?
This arc here is 360 minus x. This is arc 1.
Okay.
And then arc 2 is right here, and it's just x. So it's the difference of the two arcs is how you find the angle. It's half the difference of the two arcs.
Okay.
Okay? So then how would I go about solving for x?
Would you subtract 100 from 360?
Well, you'd actually subtract 360 from 100. And that's going to give you a negative 260 minus 2x. So you've got a negative on both sides. And so then you'll divide by that negative, and what do you get?
If you divide negative 260 by 2, it's 130.
130. So now the question was, so x is 130. So does that part of it make sense to you?
Yes.
So now what they want to know then is what is the measure of this arc here? And since it's 360 minus x, it'd be 360 minus 130, which is equal to 230.
Okay. That makes sense.
Are we good?
Yeah, because I was assuming that FH was 100, so then the other one would have to be...
Okay. Okay. Yes, definitely you need to work, you have to use what the formula is based on the placement of the angle. All right, so this question, wow, it looks massive here. Let's see if I can shrink this a little bit so we can see more of that. Nope, it doesn't want to let me go like this, maybe. All right, so this question here is just basically saying which circle shows that arc AB is a measure of 60. So this is a really good question because what it's kind of asking you is do you know what all the rules are? So for here, since the vertex is on the circle, what does that make the measurement of this arc?
For that one, doesn't the rule say that it has to be double?
Correct. So what would the measure of this arc be?
120.
120. So that wouldn't work, correct?
Right.
So here the vertex is on the circle and the same rule applies, correct? So that's also 120.
Oh, that one's 120?
It is because the vertex is on the circle, and like you just said, the rule for when it's on the circle, that's what we call an inscribed angle. Inscribed, I can't even, never mind, I'm not even going to try to spell it right now. Inscribed angle, so that the measure of the angle is equal to half the measure of the arc. So like you said, the arc is twice as big.
Okay.
Inscribed angle. Okay, so the placement of it's on the circle. Now for the next one, notice that the vertex is on the center. This is what we call a central angle. Whoops, terrible. Central angle. I don't know why I want to keep putting that R there, but okay. Central angle, so what's the relationship between this angle and the arc?
Is it equal to the...
Right.
I'm sorry.
It's equal, so it's also 60, and that's what they were asking you to find. The one that equaled 60.
Okay.
And I just want to point out that this one also has its vertex on the circle, so this one would have also been 120.
So when the vertexes are outside of the circle, or inside of the circle, is when it's double.
When it's on the circle. See how it's actually on the circle?
Uh-huh.
The circle are just these points here. This is in the inside. This is the center of the circle. So if it's on the center, then they're equal. But if it's on the circle, then it's half the measure of the arc.
Okay.
Okay? All right, so then the next one basically just says two chords intersect at a point inside the circle that's not the center. So that would look like this. You have one chord and another chord. And they intersect inside the circle. So this is what we call an interior angle. Okay. So do you remember the first one we had way up here? That was an exterior angle. That one we said, whoops, sorry, I should put something down, but for the exterior angle, remember, the measure of the angle was equal to half the difference of the two arcs. Then on this one here, we had examples of inscribed angles. That's when it's on the circle, or a central angle when it's on the center. So then the only other choice is what we call an interior. So the measure of an interior angle is equal to half the sum of the two arcs. So let's say this is arc 1 and this is arc 2. Then this angle here would be half the sum of these two arcs. And so that's what it's saying here. The sum of the measure of each pair of vertical angles is equal to the sum of the measure of the arcs.
Okay.
Okay, so then just to go over that one more time, you have four possibilities. One, your center angle, vertex is on the center. Here it's equal to the arc, the measure of the angle. The other choice is it's on the circle. This is equal to half the arc, the angle is. The other choice is when it's on the outside. This is your exterior angle. Then it's half the difference of those two arcs, because there's two arcs that it intercepts. And then the last choice is when it's on the inside. And then it's half the sum of the two arcs.
Okay.
Good?
That makes more sense now.
Okay, good. All right, so then here on this question, can you see that? I can probably make that a little bit bigger maybe. All right, it says here that you have a circle O and that A intercepts BC. Okay, so A intersects arc BC, and that angle D also intersects arc BC. So if they both share the same arc, that what you're trying to prove is that they're congruent to each other. Okay? So over here, this says, this is just your given information. But here it says the measure of angle A is equal to half the measure of arc BC. That is the inscribed angle theorem. Remember I told you that is an inscribed angle.
Yeah.
So that's what the inscribed angle theorem says. And that's just used 2 times.
Oh, okay.
Good?
Mm-hmm.
Good. All right. So I kind of went fast. There we go. All right. So here they're saying what is the measure of arc QVT, which is right here, is 156 degrees. That's the measure of the arc. So which statement must be true? So notice that both of these angles here have the same arc. Okay? So it says that our QRT and QRS are both 78 degrees. That's the statement that's true because where's the vertex for both of these angles?
The vertex?
Yeah, of the angle.
It's on the other side of the arc, but they meet at the same place, so the formula says that it's half.
Right. So angle S is equal to half the arc. And since the arc is 156, that makes the measure of that angle equal to 78 degrees.
Okay.
So this would be if they were central angles, which they're not. Good?
Okay. Yeah.
All right. So now the next one says you have a triangle that's isosceles, and this is asking you to remember some properties of isosceles triangles. That means that you have 2 sides that are congruent. It also means that these 2 base angles are congruent, that angle C is congruent to angle D. That's the isosceles triangle theorem. Now, if this arc CD is 100, what is the measure of angle B?
If CD is 100, then
Right.
angle B would be 50.
50. And since these 2 angles are the same, what's the measure of each of them? How many degrees are in the whole triangle?
That's 180, right?
Right, correct. So that's 180 minus 50, which leaves me with 130. So both of these together add up to 130, and since they're both congruent, what does that make the measure of each one?
65.
Keep trying to grab that eraser. It's not working. Right, 65. Let's see. Okay. Yeah, didn't erase really well, but all right. So what they want to know is what is the measure of this arc here? So if this angle is 65, the angle 65, what is the measure of its arc?
Double, so it's 130.
130. There you go.
Okay.
Do you see how they all keep going back to those same 4 rules?
Yeah.
Okay, this is actually the last one.
Okay.
All right, so this says here that you have this circle, and they want to know what the measurement of this arc is, TU. Now on this angle here, notice that it's in the interior. This is that interior angle. And we said that for the interior, it was equal to half the sum of the 2 arcs, correct?
Yeah.
So we're going to let this arc be x, just so that we can write it as an equation. So the angle is 94 degrees, and it's equal to half of 106 plus x, because we don't know what that value is yet. So to get rid of the 1/2, you just multiply both sides by 2. So this is going to be 188 is equal to 106 plus x. So then what do you do to get rid of or get x by itself?
You subtract 106 from
Correct.
both sides.
Correct. And that'll give you 82. Good?
Yeah. So x equals 82?
Yes, so that's the measure of that arc, 82.
Okay.
So just to go over those one more time, you have your central angle, right? That's when it's on the center. Here, the measure of the angle equals the arc. Then you
Mm-hmm.
have your inscribed angle. That's when the vertex is on the circle. So there, the angle's equal to half the arc. Then you have your exterior angles. So when you have an exterior angle, you end up with two arcs that are intercepted. And so it's equal to half the difference of the two arcs. And then the last scenario is when you intersect it and it's in the interior. You also have two arcs, so it's half the sum of the two arcs.
Okay.
Is that good?
Yeah. Thank you.
You're very welcome. Hey, as long as I have you on the line, let's go ahead and take a quick peek, whoops, at your progress report. Let me All right, let me moving slow. Okay, there you go. So you're still behind. You know, you got 24% that you've completed. You should, at this point, we're actually at the exact halfway mark today.
Okay.
So, how much time have you been putting in? Are you working every day?
My laptop has had problems, so I had been working every day, but it wouldn't submit stuff, so I'd have to like redo things. But we got it to work. We got it fixed.
Okay, perfect. All right, then why don't you try and put some extra time in this weekend and stuff and try and get caught up in the next couple days. How's that sound?
Okay, I can do that.
Your accuracy grade is 84%. Once you're ahead of target, if there are any assignments that you want to go back and redo, because I see your quiz average is only a 79, if there's anything that you want to go back and redo, you can.
Okay.
All right?
Okay, thank you so much.
You're very welcome. Is there anything else that you have questions about?
I think that's it for now.
Okay, perfect. Well, let me know right away if you start to run into trouble and stuff like that. And as you can see, it doesn't take very long to go over anything. So, just let me know. Uh,
Okay.
and I'll go ahead and send you this recording either